Welcome to the first in a series of mini-lectures about geosynthetics. We aim to assist students in civil engineering and geotechnical engineers in understanding more about geosynthetics, which have emerged as a common solution in civil engineering projects over the past 50 years. With a basic understanding of geosynthetics, engineers are better placed to understand the applications, functions, design considerations, and the various geosynthetic product categories. This program was funded by the International Fibre Centre and developed by Monash Geomechanics Group at Monash University in conjunction with the Technical Textiles and Non-Wovens Association. The program consists of 7 mini-lectures, moving from an introductory discussion through an intermediate stage, where we examine common civil engineering structures, before focusing on some common functions and applications. This topic is the introductory discussion and has been developed for second-year undergraduate civil engineers. In this unit, we introduce geosynthetic products, applications and functions to give students the sense of how widely geosynthetics are used in civil engineering today. To guide us through the introductory discussion, we will be introducing the engineering applications where geosynthetics are used and the core functions that the geosynthetic products serve within a structure. We will also be introducing the general product categories and touch on aspects of the manufacturing and quality assurance processes. So let's start with the applications of geosynthetics. Geosynthetics are used so commonly in civil engineering that you will find geosynthetic products in nearly every construction project. In this section, we define what geosynthetics are and where they are used in 4 major civil engineering sectors: engineering construction, mining, environmental, and building. Like most engineering terms, geosynthetics has a formal definition, but as shown, the definition does little to explain to the uninitiated what they actually are. Geosynthetic, a generic term describing a product with at least one component made of a planar, polymeric, synthetic or natural, material used in contact with soil, rock, and/or any other geotechnical material in civil engineering applications. In simple terms, geosynthetics are rolls of synthetic materials that are used in geotechnical applications, primarily where soil and water meet. A key part of civil engineering design is about managing the interaction between soil and water, as the presence of water can adversely impact the performance of a structure. The vast majority of geosynthetic products are buried during the construction phase, so their importance is easy to overlook. If you pass a construction site at the right time, you will see rolls of geosynthetic products being stored on site or perhaps even being installed. Having defined geosynthetics, we can now look at where a civil engineer would use them. We consider the following sectors: engineering construction, mining, environmental, and building applications. Engineering construction is essentially the transport infrastructure projects we use to move people or goods around, such as roads, railways, ports, and tunnels. Geosynthetics assist engineers in managing the performance of the soils, such as building a road over swampy ground. They can also help engineers to control the influence of water so that the structure performs as designed for as long as possible, such as keeping water out of the soils under the road so the backfill layers perform to their optimal level. As engineers create transport infrastructure in areas that are more difficult, such as roads and bridges over a river where the soils are weak, geosynthetics are also increasingly used. Here we see a non-woven geotextile being placed at the bottom of a road before the layers of road aggregates are placed. This will help keep the underlying soils from rising up into the aggregates and reducing their performance. In this railway project, a geogrid and a geotextile are being placed under rail formation to 1. Strengthen the soil underneath in order to reduce settlements, and 2. Increase the life of the ballast material through proper filtration and separation provided by the geotextile. These functions are important for long, fully laden trains moving at speed. Here we see a bund wall for a port being built on extremely weak soils. A filtration geotextile was installed to keep the fine-grained soils, essentially mud, below the bund wall structure. A high-strength geotextile was then placed to provide a strong foundation upon which the large rock was placed to form the bund wall. Without the geosynthetic layers, the bund wall would simply sink into the mud. Mining industries utilize many engineering constructions from pit to port. The use of geosynthetics increases every year in the mining industry, and common applications include tailings dams, water, wastewater infrastructure, mine rehabilitation, transport infrastructure, and dump walls. Civil engineers are generally involved in mining projects. Whilst the design life for a mining structure may be less than a highway, the extremely high loads from the mining vehicles, aggressive environments such as chemistry of mining waste, remote locations, and demanding construction timeframes make such projects just as challenging and exciting as civil construction projects. Here is an example of a tailings dam built in a remote location, where the geotextile is used as a filtration layer to allow the soil in the walls to be retained as the dam fills. If the geotextile was not used, there would be erosion of the walls leading to failure and possibly an environmental problem. You can see here that the vertical wall has to withstand the loads imposed by the massive mining vehicle. The use of geosynthetics behind the wall is quite common. Here you can see a railway being protected from falling rocks by having a rockfall drapery system being installed along the face of the cutting. If a rock falls on the railway, the train is delayed, and with the huge value of ore within every train, there is a need to ensure no delays occur. Here is an emerging geosynthetic solution, where the filtration properties of the geosynthetic tube will dewater the tailings or waste to reduce the moisture content of the material and permit more efficient disposal. Today, geosynthetics have become critical in protecting the environment from the impact of development. Valuable applications can be found in landfill and waste containment structures, erosion control and revegetation, coastal protection, architectural landscaping and low-impact sports infrastructure.